Hey everyone, my name is Spencer Behrman. I'm the Development and Partnership Manager with Sustain Dane. Outside of working at Sustain Dane, I have a lot of passions in watercolor, in drawing, piano, just the arts in general. Really grew up with my mom being an artist, and it really showed me that art goes far beyond just creating something beautiful. Does anyone else here like to create art or do art of some sort? Awesome, that's a lot of people. Then you're gonna love this next part. So growing up, my mom and I, we would always find like a nice shaded place to sit, and we would just kind of paint what was around us. Usually this was at a nearby botanical garden or something like that. And at the time, I wasn't the best at art, and all of my trees really just kind of looked like broccoli. But the combination of art and nature really did inspire me to do the sort of work that I do here today with Sustain Dane. So to me, really, the arts, they're much more than just the final project. They're a way for me to process the world that is around me, a way to express myself when words didn't quite do the trick, and it's about making something that's complex more accessible. So to speak more on this intersection of art and science, I'd like to welcome Dr. Elizabeth Maroon and Ben Ferris to the stage to speak more on a piece called Earth Signals. Let's give them a warm welcome.
So Ben and I are going to tag team this. So I'll go first, and then Ben will come up after I'm done. I'm Elizabeth Maroon. I'm a climate scientist and assistant professor in the Department of Atmospheric and Oceanic Sciences. Ben Ferris is a composer in the Mead Witter School of Music, and I'm here to tell you about Earth Signals, which is a project that I started in the last year. So if I can just sort of see around, like, raising of hands, how many of you work in, like, city government, just so I have an idea of, like, who's in the room, city, county government. How many work of you, like, in energy, utilities? How about in the medical field? Okay, let's switch this up. How many of you play an instrument, sing, or listen to music daily? This is exactly the point. Music is universal in a way that we can talk to each other about music or through music in a way that we otherwise can't. So let me see if I can change this slide here. Awesome. So Earth Signals is part of a larger research grant that I have to think about how we re-envision communication of science, in particular climate and earth science. So the background of this is I've given a lot of talks about climate change. When you are a climate scientist, you kind of feel a bit of responsibility to get the news out there, right? But I came away from many of these events that I would talk at kind of unsatisfied. One reason was, you go to a library and there'd be 7 people who showed up, and you're like, wow, only 7 people. And even worse, those 7 people all knew exactly what you were going to say because they are the ones who already care and already know. So when I was thinking about how can we envision scientific communication, I was thinking, okay, well, what is something in my own background that is going to allow me to connect with people and draw a larger audience? And music is that. I'm a classically trained pianist. And until I got on the tenure track, I was keeping up with things, and now I don't as much. So Earth Signals, which I'm going to give you the abridged version of our first concert, is a collaboration with the Mead Witter School of Music with Professor Johannes Wallman, and then we're bringing in students from the Mead Witter School of Music, students from my own department, and we're doing all sorts of ways of transforming data into science with the data into music, with the idea of how do we then put on a concert to explore really cutting-edge research topics through music. So the next few minutes, we're just going to kind of give you the abridged version of the first concert we put on. So I'm going to give you the short version. How many of you have heard of El Niño? Awesome. Yeah, El Niño is a big deal. How many of you know that we can forecast El Niño? Most of you. That's awesome. Okay. So let's go through how we do this. So El Niño is basically just the temperature in the equatorial Pacific. So you see the nice box I've got? The temperature there, that's really impacts weather worldwide. If it's warm, we call it an El Niño event, and it does one thing to the climate around the globe. If it's cold, we call it a La Niña event, because La Niña is the opposite of El Niño, and it has a whole other set of climate processes. So I'm going to tell you what the effect on the U.S. is during a La Niña, because forecasts right now say that we're heading towards a mild, weak La Niña. So when it's really, really cold in the tropical Pacific, the jet stream goes a bit north, and that means that places like Western Canada, a little colder, Pacific Northwest, a little wetter and colder. Maybe in our neck of the woods, it's kind of like a, no big effect, but maybe a little wetter. The south part of the US is drier and warmer. And this is just kind of on average. But the US isn't the only place that's infected. El Niño is the most important piece of climate variability in the system, and it affects all sorts of things worldwide. It controls how much you have diseases, vector-borne diseases like malaria and dengue, where you're going to have that in various years. It affects where you have more droughts. It affects where you're going to have more or fewer wildfires, where the water resources might be impacted. It changes the frequency of hurricanes, tropical cyclones, and it affects ecosystems. So being able to forecast El Niño is a really useful thing for decision makers, for planning for these kinds of devastating impacts. So this is an El Niño forecast from a data set that my collaborators and I use frequently. This is the exact piece of data that we used for the concert. And so this is the one that we turned into music in a variety of ways. So on the x-axis, sorry for the graphs, but I'm a scientist, you get a graph. So time is on the x-axis, and then how warm or cold it is on the y-axis. And the x is what was observed at that time, and that's where all the observations, started from. So you have a thermometer outside, and you just use that thermometer in your climate model. And then you let it go, and it gives you a forecast. Yeah, and you don't have to do it just once. You can do it multiple times because you want to have an idea of what is the uncertainty in my forecast, and we call that an ensemble system. And this is one of the really cool pieces that really connected well with the music side. It's also an ensemble, meaning that you have multiple members.
What do we need to say?
I can turn the laptop around, would that help? So we've got an ensemble forecast. Each of those lines that you saw and that will reappear momentarily is a different forecast. Each one is equally likely, and not one is wrong or right. These are all possibilities. So those forecasts that started out, they were all starting from a strong El Niño state, and they all really quickly dropped into the cold zone within the course of 6 to 9 months to a year. Cool, well, I'll just keep talking. So what happened is, it turns out that this was a really phenomenal forecast in that what actually happened fell right within that range really, really well. Yeah, yay! Thank you. So the black line here is what actually happened, and each of those colored lines is a different forecast, and it fell right within the spread. And this is an idea we call ensemble spread, the idea that it's spreading out. And then there's another idea, ensemble agreement, which is, is your observations happening within the forecast you have? That's what you want, right? And for the most part, that occurred, except at the beginning. If you notice the beginning, that black line, the observations, is actually falling right outside where all the forecasts were. The forecast wanted to go whoop, and the observations went yoomp. And so but otherwise, up until we started the actual project, this was a really good forecast. So with that, I'm going to hand it off to Ben, who's going to tell you more about how we took this concept of an ensemble forecast for El Niño, turned it into music.
Cool. Would love to start with just a bit of thanks. I think it's really cool that Professor Maroon had an NSF grant and decided to not only to have music as a big part of that grant, but then also to have students so involved in that. And I think that speaks to her work as a teacher at UW. So if we can give her a round of applause for that. When the commission came out for this piece, I thought I would apply, and I was thinking about who to, what part of the application was, who are you going to write the piece for? So I ended up writing the piece for the University of Wisconsin Bridge Ensemble, which is a group that started 5 years ago. as part of the work of the professor who I came to do my graduate work with, Peter Dominguez. He was previously working at Oberlin and had been having university groups go out to public schools in the area, basically to connect with younger students who might be interested in studying music, but also to be a resource for the school teachers. And at that time, I had just left teaching public school for 7 years and was very excited about the program. The fact that we were an ensemble that was going out to public schools in that way it seemed to gel really well with the program for Earth signals. So it was a nice fit. This group is basically the bridge aspect of it is twofold. One part is bridging. Oftentimes music groups get siloed, especially at institutions and schools, into genres of classical music, and jazz being one of the big ones that happens a lot. So this is, I think, one of the only ensembles at the university that combines those two areas of studies with a string quartet and a jazz quartet. Cool. I will jump ahead here. So my task was to basically take that graph that you just saw, all that data, and somehow turn it into music. And I thought of a lot of different ways of doing that. As a composer, you have a lot of different musical elements that you can manipulate and change and make decisions about. So some of the ones that come to mind, how about this? What are some elements of music that you all think of, or a thing that you can mess with in music? I heard pitch right away. So we could probably very simply imagine pitch related to that graph, right? We could have it kind of at the beginning go up a little, then go down, and then go back up again. And then I have a 44-second piece, all right? And the other problem there is that doesn't necessarily make us feel something related to this data, right? We have other things like rhythm. We have other things, timbre, or how things sound, groove, meter, all kinds of different things we can manipulate. The one that I landed on and ended up choosing was the idea of consonance and dissonance. This is something that we feel a lot in music. When something is dissonant, we have a reaction to it, mostly because of all the music that we've heard so far. And then when it becomes consonant, it's almost like a release of, okay, this sounds better, this feels better. So that was one of the elements that I looked at a lot in the composition. The other one was I was writing up until November, and there is, on that graph, we have a thick line of truth. Maybe the next is a bigger picture of the graph. There it is. We have this thick black line of what actually happened, right, of truth. And then eventually that runs out because we're working with predictions. And for me, that immediately spoke to improvisation, right? So when we are improvising, at a basic level, you're making things up on the spot, but those things are so influenced and changed by what has happened before and what else is happening around you. And that seemed to be a big part for me also of the data and the way that predictions work here. So I kind of thought initially the ensemble is 8 people. Here were a bunch of different lines. The beginning of the piece has a lot of dissonance because these lines start going in different directions. And then, as Elizabeth mentioned, in the middle, the predictions all kind of go down. So we have a section there of more consonants. And then at the end, I really didn't write any music because I figured we'd thought of things, we'd experienced things in playing this first 12 minutes of music. The whole piece is about 20 minutes. After that, it's kind of up to us, and we don't really know what actually happened. So every performance of this piece will have something different depending on who's playing it, depending on what we do, because there's nothing written there. I did add at the very end, I figure at some point everything comes back to being true. So the end of the piece is very consonant in that way. I think now we get to hear some. I wish I could have brought all the musicians, but they're all graduate students. It's very hard to schedule getting everybody together. So we'll play a little of the video. I'll do my best to not mess it up. One more click. This is the beginning, so we got a lot of dissonance coming up. I'm going to skip ahead a little so you can hear some of the more consonant middle part. And I'll skip ahead a little bit more too, so you can hear the freely improvised, or the part that doesn't necessarily have written music for it. try again, sorry. And so this is now coming back to that consonance. You'll hear it mostly in the strings, and then we join there. All right. Cool. So now we have a discussion at our tables, am I right? For about 5 minutes. The questions we have are, how can art and science work together to open doors? And how can we use elements of our identities to build bridges across fields?
Cool, so I'm just gonna wrap this up before we move on to the next session. I hope hearing about this different project that we've got, spawned some ideas. I don't necessarily think, okay, everybody has to go work for musicians and artists. I think the point more is, what can you bring from your own backgrounds to connect with others across field to do what you want? So this was by far, this first concert we put on was by far the most successful outreach event I've ever had. We filled up Collins Recital Hall on campus. We had almost 200 people. We also got the director of the National Center for Atmospheric Research in the room, which was, personally like a big win, because he controls the salaries of a lot of my collaborators. And it was great. And I think we also increased the reach for both, the science side as the music side. I think we had people in the audience who were being drawn by both types of things, and it meant that we both sides of this were reaching more people. So if this sounded super cool, we're doing another one this year. The theme's going to be Wisconsin weather, and it's going to be on April 20th as part of Earth Week on campus. Be Collins Recital Music Hall again. And if you're more interested in learning what we're doing at Department of Atmospheric and Oceanic Sciences, more of the hard science, check out our website, reach out to any of us. And then Ben's also got a lot of cool things going on, a couple of new releases, a couple of concerts. So definitely check out his groups like Mr. Chair, because he is awesome, as you saw. And it was, such a delight to get to work with him, as well as the next set of composers. So with that, thank you again to the invitation to come out here. I really appreciate it. And hope you enjoy the rest of the Sustain Dane Summit.